Assalamu alaikum. So the topic for today is circles, and this is in continuation with the coordinate geometry. So circles dealing with coordinate geometry, that is because we again will be having our x and y coordinates. So if I have the x-axis drawn here and I have the y-axis, and there is a circle which has the center as the origin, and we can say that there is a point which lies on the circle. Let's say that point is P, and this point has coordinates x and y. So with respect to this, let's make the equation of a circle. So if I join the center to the point P, then I know that from the center of the circle with coordinates 0, 0, as it is passing through the origin, and the circumference, which is a point P, x and y, I can see that this is the radius of the circle here. So if this point P has coordinates x and y, I can very easily make a right angle triangle so that I can say that my horizontal distance is x and my vertical distance is y. Therefore, from O up till the point, let's say the point is Q, O till Q, my base is x, and P till Q is my perpendicular having the distance, which is y units. Therefore, I can just apply the Pythagoras theorem, and I can say that it is the base square, which is x square in my case, and perpendicular square, which is a y square in my case, and this will be equal to the hypotenuse, which will then be equal to the radius, the whole square. So this basically is the equation of circle. This basically is the equation of circle with center at the origin. Now, translate the circle from the origin on the x and y axis so that now the center lies at a point C with coordinates a and b. So I can see here that P is a point on the circumference of the circle, for which again I can have the right angle triangle, so that I can see here that my base is going to be x minus a the whole square, and my perpendicular is going to be y minus b the whole square. So if that is the case, then the equation of the circle becomes, the general form of the equation of the circle will be, the general form of the equation of the circle will be base the whole square, which in this case is x minus a the whole square, plus perpendicular, which is y minus b the whole square, and this then will be equal to the hypotenuse, which for my case is equal to the radius. Therefore, this becomes radius the whole square. So this is another form, or the general form, of the equation of a circle passing through any point C on the x and the y axes. So let's expand x minus a the whole square and y minus b the whole square by applying the algebraic identity. Let's say that algebraic identity, we should know, knowing this very well, that this is a minus b the whole square, which is equals to a square plus 2ab and plus b square. Sorry, a square, which is a minus b the whole square, equals a square minus 2ab and plus b square. So if I apply that to x minus a the whole square, I should know that I shall be having here x square minus 2ax and plus a square and plus y square minus 2by plus b square, and this is equals to the radius. So if I rearrange the equation, I can say that this is x square plus y square minus 2ax minus 2by plus a square plus b square and minus r square, which is equals to a 0. So I have the constant in the equation. I can see that the constant in the equation is a square plus b square minus r square. This can be simplified to c. I can say that there is a c value representing the constant, which is a square plus b square minus r square. And from here, I can get a third generalized form of the circle equation, which shall be equal to x square plus y square minus 2ax minus 2by plus c, which is equals to 0. So this is how I can get my circle equation here. This is a generalized form of the circle equation here. So let's do more examples to solve, to understand, and to apply the circle equations. So find the equation of the circle with center -5 and 7. I have the center, which is -5, 7, and I have been given the radius, which is a 6. I know that the general form of the equation is x minus a the whole square plus y minus b the whole square, and this is equals to the radius the whole square, where we know a and b are the center coordinates of the circle. So substituting the coordinates, I can say it's x minus minus 5 the whole square plus y minus 7 the whole square, and this will be equal to 6 the whole square, meaning this is x plus 5 the whole square plus y minus 7 the whole square, and this is equals to a 36. So this is going to be the general form of the circle equation. So find the equation of the circle with center 4, -3 that passes through the point -2 and a 5. So the keywords here are, number 1, we need to have the equation of the circle. Number 2, there is a center to the circle, which is 4 and -3, and it's passing through the point which is -2 and 5. So if I just collect the data, I know that my center for the circle is 4 and -3, and it is passing through the point, like any point on the circle that can be given as x and y, and this x and y is a -2 and a 5, and they have asked us to get the equation of the circle. I know that the general form of the equation of the circle is x minus a the whole square plus y minus b the whole square, and this is equals to r square. I have been given the center. The center is there, meaning the values of a and b, they are there. It's just that the radius is not known. So to get the radius, I should know that I have the point P on the circumference. If I join it to the center, I shall be getting the radius here. That means if I get the distance PC, that would be equal to x of p minus x of c the whole square plus y of p minus y of c the whole square under root, and this should be giving me the radius value. So if I substitute the coordinates, I should say it's a -2, -4 the whole square plus 5 minus minus 3 the whole square under the root, and solving it, I should say -2, -4, that's a -6. -6 square would give me a 36. 5 plus 3 is an 8, which gives me a 64. 8 square is a 64. Under root 36 plus 64, that's an under root 100. Or I can say that the radius value is equal to a 10 here. Therefore, just substituting the center coordinates, which are x minus 4 the whole square plus y minus minus 3 the whole square is equals to the radius the whole square, that will give me the equation of the given circle. So x minus 4 the whole square plus y plus 3 the whole square equals 100 is the equation of the required equation of the given circle here. So the third question is to find the equation of the circle which passes through the points 1, 1, 2, 4 and 3, 2. Meaning if we are given a circle, there are 3 points to this circle. One is a 1, 1, the second is a 2, 4 and the third is a 2, 2. So let's say that the 3 points are here such that let's say it's the point P which is 1, 1. Then there is another point P which is, let's say it's a Q with coordinates 2 and a 4, and we have a third point which is an R, and let's say that the given coordinates here are 3, 2. Now the radius is not known to us, the center is not known to us. That means neither we can apply the center nor we can have the radius up to the circumference of the circle. So in this case we will be applying the third equation of the circle which was found after expanding x minus a the whole square plus y minus b the whole square, which is equals to the radius square. So previously we just did the expansion and we got x square plus y square minus 2ax minus 2by and plus c, where we know that c was equal to a square plus b square minus r square. So if I bring this equation to a more generalized form, I can just say that this equation can also be written as x square plus y square plus 2gx plus, let's say it's 2fy, meaning we just don't know the center. So we do not even know the sign of the center point of the circle, meaning it can be a positive, it can be a negative. Therefore, I have converted it to a plus 2g and a plus 2fy plus c, where we know that c was actually the constants which were equal to a square plus b square minus r square. In this case, I would say that c is equal to g square plus f square and minus the radius square. So I have been given 3 points on the circle and I have 3 unknown constants g, f and c, which we can find very easily by substituting the given points. That means if I say that the given point is 1 and 1, I can just substitute 1 in the equation and I can say it's a 1 plus y plus 2x plus 2f and a plus c, which is equal to 0. Or I can say it's a 2 plus 2x plus 2f plus c, which is equal to a 0. So this is the first equation that I have obtained in terms of, sorry, it should have been a 2g here. So substituting coordinates of the point 1 of the point P, which are 1 comma 1 for x and y in the general equation, I can say this is 1 plus 2g plus 2f plus c equals 0, or 2 plus 2g plus 2f plus c is equals to 0. In the same manner, I will substitute q also in the equation with coordinates 2 comma 4, so that I can say that x is to the whole square plus 4 the whole square plus 2g into 2 plus 2f into 4 again and plus c, which is equals to 0. Solving it, it is going to be 4 plus 16 plus 4g plus 8f plus c, and this is equal to 0. Or I can say it's a 20 plus 4g plus 8f plus c, and this is equal to 0 here. So this is the second equation that I have obtained for G, F and C. Now the third point that was given in the question was point R, and this was with coordinates 3 and 2. So let's substitute R also in the equation, R with coordinates 3 comma 2. So the equation would be x square, meaning 3 the whole square plus y square, meaning 2 the whole square, plus 2g into 3 plus 2f into 2 and plus c, which is equals to 0. Solving it, it's a 9 plus 4 plus 6g plus 4f and plus c, that is equal to 0. Meaning this becomes a 13 plus 6g plus 4f plus c, and that equals a 0 here. So this becomes the third equation. So 3 equations, 3 unknowns, meaning I can solve the first 2 simultaneously to get one g in terms of f or f in terms of g. Doing that, I'm just solving 1 and 2. Equation 1 and equation 2, that was 2 plus 2g plus 2f plus c equals 0, and the second equation was 20 plus 4g plus 8f plus c equals 0. So if I solve them simultaneously, I can see that I can eliminate c very easily. C minus c becomes a 0. 2 minus 20, that's a negative 18. And then it's a negative 2g and negative 6f. This is equals to 0. Or I can just take negative 2 common, so that I'll be left with the 9 plus g plus 3f, and this is equals to 0. Therefore, the equation that I obtained is 9 plus g plus 3f. This is equals to 0. So now here at least I can have g in terms of f, and I can say that g is equals to negative 9 and negative 3f. So this is one equation that I have. Now I can solve for equation 2 and equation 3. So solving equation 2 and equation 3, it's your choice. You can solve equation 1 and 3 also. So equation 2 and equation 3. So equation 2 was t plus 4g plus 8f plus c equals 0 and 13 plus 6g plus 4f plus c equals 0. Again, I want to eliminate c, therefore I will take the difference and c gets eliminated. It's 20 minus 13, that would give me a 6 and a minus 2g and a plus 4f, which is equals to 0. So I already have g in terms of f, so I can substitute that g here. It's a negative 9, negative 3f plus 4f, which is equals to 0. Solving it, I can say it's a 7 plus 18 plus 6f plus 4f, that equals a 0, and 18 plus 7, that gives me a 25 plus 10f, which is equals to 0. Or I can say that it's a 25 which equals a negative 10f, or solving it, I can say that my f value is a negative 5 divided by 2. So I have the value of f, which is a negative 5 by 2, and I can also say that it's 2f, which is equals to a negative 5. So substituting that for g, which was negative 9, negative 3f, I will say it's g, which is equals to negative 9, negative 3 times negative 5 by 2, and this would give me negative 9 plus 15 by 2, or I would say it's the g value, which is equals to a negative 3 by 2 here. So this is the g value that I have. Also, I can say it's 2g, which is equals to a negative 3. Now the third value which is left is the c value. So I can just pick any of the equation and substitute f and g there. So if I pick equation 1, which was 2 plus 2g plus 2f plus c. So substituting g and f in equation 1, and equation 1 was 2 plus 2g plus 2f plus c, and this was equal to 0. So to find c, I'm just going to substitute Now, this was the reason that I was getting 2f and 2g, because in the first one, I just had a 2f, I had a 2g, so I'm just going to substitute the values for 2g, which is a negative 3, for 2f, which was a negative 5, plus c equals a 0, or this becomes 2 minus 3 minus 5 plus c, which is equal to 0, or it's a negative 6 plus c, which is equals to 6, or c will be equal to a 6 here. So I have g, I have f, I have the c value. I do have the general equation of the circle function, and the general equation of the circle function, as we did earlier, was so this was the general equation of the function. Substituting 2g, 2f, and c, I can say that this is x squared plus y squared. The 2g value was a negative 3, therefore I'll say it's a negative 3x. 2f was equal to a negative 5, so I'll say it's a negative 5y, and c is a 6, therefore is a plus 6, which is equals to 0. So now I have obtained the general equation of a circle by the 3 points which were given on the circumference of the circle here. So this is how we will be solving and making the general equations of circles.